Okay. So the recording is started, I think. So I'll be making buddy groups, three people in one group. Okay. Now, fine. We can have Aryan, Aziz, and Devang as one group. Nikhil, Shivani, and, Gayatri in the second group. Azni, uh, Harshavardhan, and Yash, and Kashish, Neeraj, and who is remaining? Shivani, right? So Kashish,
No, mine is already done.
yours is done.
Yeah,
Okay.
with Gayatri and Nikhil, I guess.
Okay. So
Sorry, sir.
Kashish,
Sir. Sorry,
yeah.
I think you mentioned my name twice.
Oh, did I?
Yep.
I have not been counted.
Yeah. Okay, wait. So Bhaskar and okay, wait. So can buddy group one people just raise your hands? Whom I told? Aryan, Devang, and
Me.
Azni. Okay.
Yep.
Fine. So Aryan, Devang, and Azni, one group, group one. And what was the second buddy group? Second buddy group, can you raise your hands? It was Nikhil, Shivani, and Gayatri. Yeah. So Nikhil, Shivani, and Gayatri, second buddy group. The third buddy group, Harshavardhan, Yash, and okay, Azni was called twice, right? In that case, so we can have Harshavardhan, Yash, and Bhaskar in the third buddy group. And what about the fourth buddy group? It was Kashish, Neeraj, and so whose name is yet to be called? Gayatri, I think, right?
No, sir, my name was called. I was team 2.
Oh, okay. So who is that? Like we have 12 people. One person is missing.
Sir, actually, it's Kiana Sindhu has I guess accidentally joined twice. That is why it is showing 14.
Oh,
Yeah, so it is
yes.
just 13 people.
Okay, fine. So Kashish and Neeraj, okay, fine. We need one more person, right? Do you guys know any online who's active but not joined today?
So Dishnia maybe?
Yeah, yes. So yeah. So can you guys team up with Dishnia? Kashish, Neeraj, and Dishnia?
Okay, sir.
Yeah, just contact her and maybe she is busy in shifting to IIT Madras currently. So she might take a few days time, like 1 or 2 days. Okay. So Kashish, Neeraj, and Dishnia as the fourth group.
Okay, sir.
Okay. Thank you guys. So anybody please kindly write down this team names. Team 1, these names. Team 2, these names. And put it in the group. Okay. And I think Sujit is joining now. So as informed, I want each buddy group to choose one of the mathematical model. And so team 1 and team 2, Sujit will be explaining the mathematical model tomorrow. Like brief explanation, what you have to do and all. And team 3 and team 4, he will be explaining on Wednesday. And take 4 days time. So July, okay, July 31st will be having team 1 and team 2's presentation, and August 1st will be having team 3 and team 4's presentation. Fine. Okay. We'll wait for Subjit. Please stay in the call. And in the meantime, guys, if you have not filled the feedback form, please kindly fill it. And one more thing is, if you want your testimonial to go into our website, just put a nice DP of yours or any photo, so that we'll consider that as you have accepted to put your feedback in our website. Okay. Hi, Sukhjit. Okay, he's not listening yet. Hello, hi, Sukhjit.
Hey Sagar.
Yeah,
So should we wait 2 to 3 minutes for the people to join?
I think it is these many people only, Sukhjit.
Actually,
So
it's quite.
what I made was, yeah, tell me.
Yes, go ahead.
So actually, I made 4 buddy groups of 3
Okay.
people each currently. And in case if people want to join further, I'll put each people who join into the same buddy groups, like group 1, group 2, or something like that. Okay.
Okay.
Yeah, we can start now, I think, to explain the mathematical models.
Okay, guys. So let's begin. So welcome to the class, everyone. So as Sagar may have, Sagar, have you already told them about how we will be beginning, like the buddy groups and the project, or should I explain that? Sagar, are you there?
So the buddy groups and we were already told about what we have to do. You just need to assign us the topics now. You can go straight ahead with that.
Okay. So I'll be explaining to each and every one of you the different types of models that we have. So today we will be studying through a book rather than the presentation, because for this you guys will need to refer to a lot of books. So for that we decided that okay, we will show you a reference book that you can refer. It would be up to you, what type of reference material you guys can come up with. However, we will be referring this book to you. Sagar, can you please allow me to share my screen? It's saying here that the host has
Yes,
disabled.
I allowed it.
Okay, thanks. Have you allowed?
Yes, I allowed it.
Got it. Thanks. So, okay. So is my screen visible?
Yes.
Okay. So everyone, this is the book, Mathematical Modeling with Case Studies. It is a book by Belinda Barnes and Glenn Robert Fulford. So this book explains how to do analyze the models using Maple and MATLAB. So you guys, for doing the analysis part, if you guys, since we have chosen Python for our as the software that we'll be working on, so do not focus on the code aspect of this, rather than focus on the theoretical aspect. Okay, so we will be, as Sagar may have already told you, I'll be explaining the different type of models that we have here. Okay, there are a lot of models like battle model. There's influenza model, that is the COVID pandemic model, and other type of models that we have. So just to update you that we will be assigning different type of models to you. Now the objective of this will be that since you have already learned through our two models, like the population model and the predator prey model, that how mathematical models are made and how we actually different like we perform analysis of the model through we did the practical study of one during our last session in the predator prey model, where we actually applied all of the codes and we saw, okay, this code compiles like this, so it shows this, and this is the analysis that we can make from it. You already have the zip folder also for the Lotka Volterra model. It is showing the different types of analysis. So through this study, what you will be doing is that each of you would be getting one specific models and you will be performing analysis of it. So now we don't have any specific models in mind as of now as to we will be assigning which buddy group which. I'll be providing a 5-minute discussion of some 4 to 5 selected models here, and whatever guys each buddy group wants, the group can ask for that. So is that clear?
Yes, yes.
Okay. So the first that we have here is the lake pollution model. So it's on page number 20. So let's go there. Yeah, this is it. Lake pollution models. So, okay. So let's begin. So guys, let's think of a closed lake structure. Yeah, just to update you, notify you that today we will be only studying about these models on a very basic perspective, just to tell you that what we will be doing in these models. More focused discussions on these models will be done on Tuesday and Wednesday, where we will be studying about each of these models in detail. So let's go through the background of the lake pollution model. So what lake pollution model is about? So think of not a lake but a swimming pool. And what a swimming pool has is there is one pipe that supplies the water, and there is one pipe that filters out the water. Okay, so now keeping this like this structure in your mind, let's focus on it. So the pollution in our lakes has become a major problem over the last 50 years. So in order to prevent the situations, we have made a lot of analysis over time to how we can improve it. So this is the compartment model that we have. So now see if you think about this whole structure, this cuboid as a lake, as a swimming pool. Okay, so in that we have the mass of the pollutant in lake. So suppose that lake is infected with the particular material. It can be any type of material. It can be excessive volcanic ash, excessive soil, or plastic. So there is in order to find the mass, we have a mass inflow rate from where the mass is being provided, and there's a mass outflow. So in order to have that, so this leads us to this word equation. So rate of change of mass in lake would be equal to rate at which mass is entering the lake and rate at which mass is leaving the lake. So the lake pollution model is actually a study of where you will be studying at the rate at which is entering, at the rate at which it is exiting. It actually looks like quite a simple kind model, but as you will study it, there's this model actually has a very like applied applications on a day-to-day basis. So it's actually used by scientists in their daily life because the rate at which the pollutant is and the rate of change of mass in a pollutant in a particular area does not have that much specific characteristics, but it does is a quite interesting equation, which leads to a lot of interesting studies. So this is one of the models that we will be doing here. After that, we have some further like advancement that we will be also making it. So this is one of the equation, dc by dt is equals to this one equation. After that, they have just explained integrated it. So this is the equation that wait. Yeah, this is the equation here, and this is the concentration at any time t. This is the limit t. We will be studying about each of the how it tends to infinity and other kinds of like whatever kinds of analysis that we can think of. So this was the first model, and after that, we have here drug assimilation into the blood. That is on page 28. Any doubts related to the lake pollution model?
Sujit, can you just zoom in the PDF a little bit?
Okay, sure.
Little more.
A little more. Okay.
Yeah, fine.
Thanks. So drug assimilation into the blood. So I must say this is actually one of my favorite models, and whatever team chooses this would be one of my favorite teams. So, okay, now try to think that whenever you drink, as we explained earlier, that mathematical modeling is about that type of study that we can apply to any system as long as there's an intake and there's an outtake, or even just an intake or an outtake even. It's just about studying that. So keeping this in mind, so now whenever we drink like any type of fluids on a daily basis, or even we eat tablets or we take drugs and anything for medicinal purposes, or even when people drink alcohol, we have a good understanding that our body actually filters this out from our system, because when it detects this, as I'm sure we have all read it in our class 9th and class 10th, that how our immune system, it actually finds these when it would characterize these functions as foreign contaminants in our bloodstream, whatever the nature of we have taken. Like it could be a good medicine, but to our body it's still a foreign contaminant. So to do that, our body starts filtering these contaminants out of our model. So this model is actually about that. See, now in the following example, we see that different drugs are absorbed into and extracted from the blood at very different rates, because every tablet or anything else is in some way a drug, or there are some antibodies also. So the antibodies are actually living organisms. So so the rate at which each of those contaminants are filtered out of our bloods, they vary. So it's just like how a normal fever and like a fever that's like suppose 100 and 103 fever, the rate of infection varies. So the rate of absorption at which these are being filtered out of our blood, it varies. So the drug actually dissolves in the GI tract, that is the gastrointestinal tract, and each ingredient is diffused in the bloodstream. They're carried to the location in which they act and then removed from the blood by the kidneys and liver. The assimilation and removal may occur at different rates due to the different ingredients of the same pill. So this we have already discussed. So this is about that how the drug goes to the GI tract. It is after getting digested, it is transferred into the blood, then tissue. And this after it passes on to the tissue, we can assume that it has served its purpose and it will be filtered out by the blood. So we have to model that how the rate of drug changes in the GI tract and rate of change of drug in the blood. So we will be analyzing this here. So rate of change of drug is equals to drug intake minus drug outtake through the digestion, and rate of change of drug in blood is equals to rate at which drug is entering the blood through a digestion, and rate at which drug is leaving the blood through the tissues. So this model is about that. So yeah, this I must say, this model may look like a complex one. It's actually a very simple one if you will look at it, and it has a very similar understanding as to the previous model that we were just doing. So this is the second model. And yeah, and if any team like when we are explaining the models, if any of the teams they want the select the model right away, then please do let us know about that. And we have the lake pollution, we have the drug assimilation. Yes. Okay. So Sagar, you've seen the message. So Bhaskar, which group are you interested in? Like which model? The GI tract one or the lake pollution one? Okay. Sagar, please note it in the group, or else you if you guys can drop a message in the group. Okay, then please discuss that with them, and then you can let us know after the meeting itself then, or even during the meet. Okay. Okay, let me find this. Epidemic model for influenza. Okay, one of you also asked in advance about the influenza model. So we also that how we can model the influenza model also. So today we will be discussing about that, an epidemic model for influenza. So as we all know, the influenza is a disease. So now here we will be developing a model to how to model the spread of influenza in a boarding school. Sure, Sagar. Okay, so yeah, over the centuries we have all seen, like it was for the COVID, and for a number of models we have always seen that AIDS, Ebola, COVID, influenza, the rates at which they spread, it varies from region to region. Like for India, the spread was quite slow at first, and then it started growing at a very fast rate. For America, it started at an alarmingly increased rate from the initial period, and same can be said for China, Australia, Europe. So to understand how these things happen and why they happen the way that they do happen, we develop these influenza models. So yeah, so in the case of, we can see that like there are some individual models, and so here we will be studying two class, a susceptible class and the contagious class. So susceptible class refers to those that we suspect them, okay, they may be infected, or supposedly we have an age group at which the people are getting infected, so we say that okay, these are susceptible, and then we say contagious infectors, which are already been infected. So we will be communicate so these are some assumptions that we have. We assume that the birth and death rates, ignore the birth and death rates, and assume that disease is spread by contact. You ignore the latent period, and so these are some assumptions that we make. And yeah, rate of change in susceptibles. So what we have is one, the rate at which the rate of change in susceptibles, rate of change in infectives, and the third class that we have is rate of changes in recovered. So some infectives, they recover from the disease. So what we say is that infected have developed an immune response to the recovered the recovered have developed an immune response to the virus. So they are recovered and they will not be infected with this virus for some period of time. Let's say 14 days, 15 days, a week, 2 weeks, 1 month, 2 months. So it's not entirely known and depending on the nature of the disease. So these are some of the things that we will be studying around it. So this is known as the influenza model. So this one has 3 compartments. So, but even the number of compartments do not depend that much because we will be explaining you everything, and it will all come down to the understanding that you can develop. So influenza model, and after that we have battle model. So in this we will be actually studying about how when we let's say that 2 armies are fighting with each other. So how can you mathematically model which army is going to win and which army is going to lose? So this is that. So let's assume that there are 2 armies. I'll keep it short because we also have to organize the activity. So let's assume that there are 2 armies, red army and blue army, that are fighting with each other. So okay, so we say, so the only way, see, this is what we say, that it is a closed model. Okay, just give me a second. Okay, so this is what we say is a closed model. Whenever the armies fight on a daily basis, there are 100 people, let's say, fighting from red side and 200 people fighting from the blue army side. So the army number is contained, like there's not more armies that are coming. So what we do is that, let's say that 100 and 200 armies, they are in a battlefield and they are fighting with each other. So there is not an increase in their population because all the armies have already been kept in the battleground. So the only way that they would be killed by the opposing army. So what we will do, how we will model it is that the rate of change of blue army, the rate of change of red soldiers is the rate at which the red soldiers are wounded by the blue army. Because if the other person is wounded, or even if they are killed during the battle, they are not in a functioning state to fight with the other person. And the rate at which the blue soldier is the rate at which the blue soldier is wounded by the red army. So this is the rate. So rate at which the red soldier will be wounded by the blue army. So now that would depend, would be proportional to the rate of at BT. So BT denoting the, let's say, the number of soldiers of the blue army. So we only say that the rate at which the red army is being killed is directly proportional to the number of blue army at that particular time. A1 is just the proportionality constant. The same is for the blue soldiers. The rate at which they are killed is A2RT. So these are the equations that we have. So we will be analyzing these following equations also. So these are the 4 mathematical models. Please let me know if you have any query or anything related to this. Okay, if you guys don't have any models, so Sagar, I think we can wrap up today's session. We only had to discuss about the models. So please discuss.
Okay.
Yes, Sagar, go ahead.
Yeah. So what we can do is, don't leave the call, guys, because we'll be having an activity by Sindhu now. Okay. So yeah, so discuss between your teammates and first come first serve basis. So if two teams are asking a particular model, which team will ask first will be getting it. Okay. So can you share this book to the in the group?
Yes, Sagar, I'll do that right away.
Sujit?
Yes.
Yeah. Fine. So discuss with the teammates and come up with the final topic, guys. Tomorrow we'll be having a meeting with buddy group 1 and 2. Okay. Is it fine, guys? Can buddy group 1 and 2 make it tomorrow? Can I get response from them?
Yes, sir.
Devang, Kazni, and others.
The buddy group 3 and 4 can join, like if they're not available tomorrow, we will be having a session also on the Wednesday where we'll be discussing the two subsequent models of the buddy group 3 and buddy group 4. So yeah, if anyone wants to join in for their own curiosity, then they are like welcome to join.
Yeah, and kindly give your decision by end of today night. Okay, like before today ends, kindly give your decision. Yeah, I think Sindhu, we can begin your activity now. Thank you, Sujit.
Okay. Thank you, sir.
Yes, Sindhu, we can start.
Yeah, 2 minutes. I'm just sharing my screen.
Hello, am I audible?
Yes, ma'am.
Yes,
Yeah.
yes, you're audible.
Okay, this is a very, very simple activity. As Jatin had explained already what is a Cephide variable, I'll just go through it again quickly and then we can do the activity. So Cephide variables are a class of variable star which shows periodic variation in their brightness, that is the stellar magnitude. So before, so we all know the parallax method, which is used to calculate the distance, but then you cannot calculate the distance of a star or a galaxy or a cluster that is a million light years away or 20 million light years away. Parallax method is not suitable for that. So as you know, Henrietta was the one who had discovered the Cephide variables. She was also the one who had found out the period luminosity formula. This was from her paper. I actually tried to find the derivation for this, but I could not find it. But this over the period of time, this formula has been revised and changed. But currently, this is the formula they've been using. If you Google like the Wikipedia page, it shows here minus 4.0. So that is the old one. So this is the revised one. So over the period of years, they have revised the period luminosity formula. So this is the formula you'll be using. Can you see my screen?
Yes, yes.
Okay. Yeah, so this is the formula. So where m is equal to minus 2.78 log to the base 10, that is, okay, of p, that is the period, minus 1.35. So where m is the absolute magnitude of a star and where p is the period measured in days. So, okay, if you can open the printout, like, okay, if you have the printout, okay, I'll just show you before that. So this is, can you see this, the circled one here? Can you see that P8, P5, P6, V6? So these are the observed variable stars in the NGC 3109. So what you have to do first is to calculate the distances, find out the number of Cepheid variables that is there in the in the NGC 31 in the galaxy or a cluster which you are trying to measure, and then you have to find out the distance of the each Cepheid variable, take the average of a distance, and that's when you find out that's when you get the distance of a galaxy or a cluster, like how far they are. So that is what you guys are going to do. So instead of we taking lot of Cepheid variables, we can, for the activity, we like I've chosen 4. Oh, sorry, 4 or 6. Yeah, for the activity, yeah, it's the 6. So this is the way you have to do. So first thing, so this is the graph. Okay, so this is the period, like how the Cepheid variables have been pulsating. Okay, so this is the V6, V7, V34, V35, V64, and V72 Cepheid variables we have taken. Okay. So first thing what you have to do is, and also you guys already know the distance modulus formula, so we're going to use that also. So first we have to measure the minimum apparent, so we'll be measuring the minimum apparent magnitude and the maximum apparent magnitude and take the average, and then we'll calculate the distance. Okay, so I'll just tell you how to, what and all you need. Okay, the tabular column, okay, here. Okay, the first column, Cepheid number, you just have to write that V6, V7, whatever Cepheid variable star you're taking, this one. Okay, and then here, T2, T1 at the period, this is M max and M minimum. That I'll tell you here. Okay, 1 minute. Yeah, can you see this? Can you see this arrow? Hello?
Yes.
This one here, which I'm moving.
Yes, it is visible.
Yeah, okay. One. So this will be your M max, okay, which you will be filling it here, okay, in this column. So that will be the top of this exactly, okay. So this one, okay, this black circle. So this will be your M max. Simultaneously, this you can take either this or this for your M minimum, okay, like this or this one here. Okay, so this will be your M minimum. So this is your M max, this is your M minimum. And similarly, the T1 and T2, oh yeah, before that, so this is on x-axis, it is apparent magnitude, y-axis, it's the period of days. So here you can take this as 25, 50, and 100, like in days. Okay, so this is 0, 25, 50, and 100. And this is again 0, 25, separate this, these are separate. So yeah, you understood the M max and M minimum, right? So now it is T1 and T2. Similarly, 1 minute. Yeah. So this will be your T1 like this. This will be your T1 and this will be your T2 here. This will be your T2. Okay, so this is M max, this is your M minimum, this is T1, and this is T2. It is similar for other variable stars also. V7, this X mark, which you can see here, X plotting. So that will be your M max. And here anywhere, so here it's a cluster, right? So you just have to guess and then take a midpoint of it, and then that will be your M minimum. And similarly, this will again take a midpoint. This will be your T1 and this will be your T2. So do the same thing for like all the other stars. And then here first fill the T1 and T2. Period will be T2 minus T1. This M you have to calculate from the formula, that is m is equal to minus 2.78 log p. So this period here, p, you will be substituting this one, the T2 minus T1, which you will get here, that will be your p. And that you'll be substituting here in this formula, that you'll get the absolute magnitude. And then you have to write m max and m minimum, take the average of it, and use and substitute all of this in the distance modulus formula. That is m minus capital M is equal to phi log D minus phi. Here the same way you have, since you guys calculated the problems using the distance modulus, same thing here, you have to calculate the D like for all the specified variables, take the average of it, and that will be your distance, like for the distance of the NGC 3109 from us. That's how you calculate using the specified variables. Again, like I said, here we have taken just 6, since there are a lot of them. So you just have to take all their distance, get the average, and you get the distance of that cluster or a galaxy that you're trying to find out. Yeah, any doubts?
What does the X's and O's represent?
This one, right?
Yeah.
Yeah, this was actually it is taken from a paper. So they were studying the variables. So the black ones were already studied in the 1932's paper. So it was just that they have revised it. So it is nothing. It's just that like 3 different people have tried this. So it's 3 different datas of it, which is actually showing that it is the same over the period of time.
So if we take the black, what are we exactly supposed to take? The X's or the black circles?
Oh, yeah, that's what I said, right? Like if you look at the if you look at the V7, you can take the average of this. Like make a guess. Like I'm telling, like to a like let's say this one, like here, this point yeah, let's say here, and you can take like this. This will be your T1. Sorry, or T2. Oh, sorry, that will be your T1. Yeah, you can take like this. Just 1 minute.
So then will I be taking measurements of just X's throughout for all the 6?
Sorry, yeah, can you repeat?
So will I be taking X's for all the 6 graphs?
Yeah, that's what I'm saying. It's not X's or the black circle or the white circle. See, just take an approximate distance.
But then since you said there are 3 different models that are shown, so I'll be taking different distances from different models, right?
that doesn't matter. That doesn't make any difference.
All right.
Yeah. Oh, about last but one column. Wait. Which one? This M? This one? So yeah, that is the average of the apparent magnitude. 1 minute. Yeah, you get the M max and M minimum, right? Just add and divide by 2. You get the average of it. This is just the average. Yeah.
What is the physical significance of M max and M min?
Yeah, so that is what. So M max is where the specified variable is the brightest, and M minimum is where the specified variable is at the lowest brightness. It's pulsating, right? So when it is pulsating, like let's say it's going out, so its brightness is there, and it's dimming up, so that is M minimum. Brightening up is M max, dimming is M minimum. That's why you get the curve like this. Anything else? Any other doubts?
Okay, so guys, now since you have understood the activity and we are short of time, I don't want to extend it more than 1 hour today. Can you all try to do this activity? Just take a printout of this document. Just do some calculations and find out the distance. And I'll open an assignment. I think there was no assignment for past 2 weeks, right? So I'll open an assignment, and is it possible for you guys to submit it this weekend, Saturday or Friday, anytime? This might not take more than 30 minutes, I think. That's all.
Yes, sir.
Okay then. So thank you for joining us. So discuss your teammates right now or after this class, and come up with choose the topic before before today, okay? Because Sujit want to prepare for tomorrow, right? Tomorrow team 1 and 2 will be having explanation of the mathematical modeling. Okay then. Fine guys. Bye bye.